Hello, I'm Brian Robison, Chief Evangelist at BlackBerry. Over the past few months, we've seen a literal explosion in cyber attacks focused at us at home rather than at our offices. The predominant methods being used right now are phishing and weaponized email attachments. I plan on giving you a glimpse into the mind of the adversary in today's Learning from the Adversary, a look inside the techniques of Ocean Lotus, also known as APT 32. In today's talk, we're going to break down two different examples of APT 32's work and look at how they weaponized attachments and how, in some cases, they evaded detection by network and endpoint security products. The attacks I'm going to talk about today are considered fileless attacks. Let's begin by exploring why fileless attacks matter. A Ponemon Institute study found of the respondents, 54% of them have experienced some kind of breach. Of those, 77% were found to use fileless techniques. This study was done back in 2017, and these numbers have risen significantly since then. We are seeing a huge increase in the quantity and effectiveness of fileless attacks over the past few years, and thusly we've seen a decrease in the use of executable malware being the cause of a breach. Let's define and examine the attributes of a fileless attack. Fileless attacks are defined by attacking but not generating files on disk, thusly triggering traditional AV scans. However, a fileless attack is not usually a file-free attack. Fileless attack is sort of a misnomer in this situation, as most of these attacks begin with a weaponized document, which is a file. But the files are not the traditional executable type of code like an exe or DLL file, at least not in the first few phases of the attack. They don't write new files to disk, and this is the best way to avoid AV detection is to not trigger a scan. These methods are most commonly found in the initial phases of an attack. Usually the fileless portion of the attack is at the vanguard of the breach. Once in and connectivity is established, the attacker will usually utilize already existing and trusted tools to continue the attack in a method known as living off the land. Again, using tools that are already installed and trusted is a great method to bypass traditional security. No new EXEs are needed to further the attack. Sometimes, but less often than one would think, a true zero-day vulnerability is found that the attacker exploits to their advantage. Again, it is far easier to attack the human and get them to run your code for you than it is to exploit software. So how do these attacks happen? In general, these attacks begin with a weaponized email attachment. The attackers are getting better and better at social engineering, and at several points during this demonstration, you'll see where hacking the human is a key part of these attacks. The attack usually begins when the user receives an email with some great social engineering, convincing them that the attachment is important and is safe to open. They open the attachment, and this is the critical pivot point, the application warning. Most applications have decided to pass the buck to the end user when an action could cause harm. The user ignores the software warning and clicks on the OK or Continue button. Game over. Now the embedded script runs, which may not even be malicious yet at this point, but usually the goal is to establish command and control over the endpoint, and this is also known as C2. Once this is up and running, the system is now compromised and can be used to move laterally or even deploy some nasty ransomware that will take out the system and everything else in the network. Okay, enough theory and presentation. It's time to head into the lab and demonstrate how these attacks are built and operate.
Let's begin our demonstration. Now, in today's demonstration, we're going to use two different styles of fileless attack, both employing social engineering to get the end user to run the attack for us. Now, let's begin by explaining what we're looking at here. So on the right-hand side of the screen, this Windows box, and we also have a Mac box that's running, these are our victims. These are the machines that we're going to attack. Now on the left-hand side of the screen, we're going to see our Kali Linux box, which is our attacker. And we're going to use a tool today called Trevor C2, Trevor Command and Control. The Trevor server is essentially set up, and we're going to go ahead and start it and get it ready to listen to clients. Now, the clients are sitting basically in the same directory, and there's a PowerShell client, and there's a Python client, and it just simply needs a very simple web server to run that we can use to download that client, execute it in memory, and then when the client is executed, it will then connect back up here to the command and control environment. So a very common scenario, but a very successful and very cool tool for you guys to use out there when you're trying to reproduce this attack or these types of attacks in your own environment. So let's move on to creating the attack. Now, as I said before in the opening, we're going to attack the human. And what that means is that we're going to be an expert today in social engineering. We're going to trick the user into executing our code on our behalf. Now, the first thing that we're going to look at is an attack called DDE. And this is a very old feature that's built into Microsoft Office. And it allows you to pull data in from other sources and use it in your documents. So building a smart document. So similar to macros, but actually allowing you to execute, SQL queries and other things and pull that data into different fields in your document. We're going to use this resume. This resume document actually contains a macro. In most cases, macros are actually good for business. We use macros all the time to do things like automatically update fields in the document with other information like addresses and other things like that. So the end user is warned, of course, that this is potentially dangerous to their organization. Now, in this case, this is a good macro that is actually embedded in the document. And all it's going to do is update my name and initials here in the header graphic. So we're going to click Enable the Content. And you'll see, yep, it updated my name and initials into the header. We're going to put macro discussions off for a little bit longer, and we're going to go back. We're going to focus on the DDE exploit that we're going to put in this document. To do DDE, what we're going to do is we're going to put a new field in the document. And the easiest thing to do here is to put it in line, let's say, with the end of this first paragraph. And we're going to insert a field. Now, the field can pretty much be anything you want because it doesn't really matter. We're going to replace the text anyway. You'll see here it says unexpected end of formula. So what we're going to do is we're actually going to delete all of the text except for the exclamation point, and that makes it visually, grammatically correct. However, if we click over the exclamation point, you'll see a light gray around that, and that actually means that it is a field. We're going to look at the code of the field by toggling the field code. We want this, instead of running something directly, we want this to be a DDE. So we're going to make this a DDE script that we're going to run, and we want it to, of course, auto-run when the document is open. Now, to save time in typing, I've already got this written, so we're going to just copy this text, and we're going to paste it in. This command, you'll see a little bit more about it here in a few minutes, but what it looks like is we've got something that looks like a path. We can see PowerShell. We can see the command to execute the PowerShell script directly into memory versus storing it onto disk. Then what it's going to do is it's going to open a web connection and download from our little web server over here. It's going to download the Trevor client PS1 and execute it in memory. There's this text here called blah, and what the heck is blah? Well, this is just a visual reminder for me to actually change this text. And we could change this to really anything we want to change it to. So maybe we want to, use our social engineering to say that this is, okay by security, as an example. Now, it doesn't make a whole lot of sense why you would do that here, but what this actually does is actually modifies a built-in Microsoft Word error dialog. And we're going to see that here in a few seconds when we run this attack. So we're actually done weaponizing this. So we're going to toggle our field code back to hide our text, and we'll make it grammatically correct. We just know that that little exclamation point there is a field. And we're just going to close and save the document. Now the interesting thing is when we reopen this document, the macro is actually still going to run because we saved the decision whether to run that macro or not with the document. But again, we know that that macro is innocent. It's just going to update the name. And then when the Trevor client executes, that's going to be a different thing. And so now we're going to go ahead and run our weaponized document. Now, notice we didn't get the macro dialog because we've already told this file that it's okay to run that macro, and so it did. Now we get a different type of message. Now this is a DDE message that you're going to get. So training the user on, only click on, don't click on the yellow bar doesn't pertain to this because this is a different error dialog. And again, through social engineering, we can tell the user that they should click yes on this. They need to download that data so that they can get that discount code or that they can get that inventory update or whatever it is. We trick them into clicking yes. Now, no code is actually running at this point. It actually hasn't executed or downloaded the PowerShell and attacked or anything. So they can get in here, they can click yes, and now we get this new dialog. Now this error dialog is the one that we can modify. So in parentheses here, we can see that text that we typed in, OK by security. Now that's sort of crazy because this is a Microsoft Word error message, not something that's generated by the attack or anything else, but we can actually inject text in here. And so you can see here, again, further social engineering, the remote data OK by security is not accessible. Do you want to start the application? And then there is actually that fake path. And again, the goal here is not to be necessarily 100% perfect. The goal here is to get just enough to bypass that human who's going to say, yeah, that looks pretty legitimate. I'm going to go ahead and click OK. And then you're going to get another string, another error dialog, but it really doesn't matter because the attack has actually been running in the background. And we should see here in a few seconds, there it is. We see the website get hit and download the client, and then the client executes and is now connected to the command and control. So, and there's no way out of this. Essentially, you can click OK or hit X, but it gets into this loop. So it doesn't really matter. We can click no here. It doesn't really matter. But the great thing here is that the end user doesn't see anything running. And even if you were looking at this with Wireshark and looking at the network communication, all you would see is this machine hitting those URLs with those encrypted GUID strings. And so it's a really cool command and control to use for that. So on our command and control, we can see the different systems that we have actually connected to our command and control, and we can go ahead and begin interacting with them. Now, what we're going to be doing is, like I said before, we're going to be putting commands that the client is going to execute. We're going to be putting those commands up on our website, and the client is looking for those commands to be there. So there's going to be a delay between when I type a command and the action that actually appears on the endpoint. So we can do something, very simple, like let's go ahead and start a program like calc. And you'll see that the command will be put on the website, the client will check into it, and all of a sudden, within a few seconds, we have the calculator pop up on our victim system. So we know that we actually have a command and control over that environment. In fact, we can do something like get a directory of the current path that we're in. Again, the command is posted, and it waits for the command to come back, and then the response back into the shell here. And you can see we're sitting on the desktop of that user. And then we can do something even more fun, like we can actually begin to kill processes, for example. Like we can kill the calculator that we just started. And again, that that lag between when the post when it's posted and when it comes up, and I must have typed something incorrect. There we go. So that's what I did. I just put the the command name goes in between. So we can continue to kill other programs like WinWord.exe, and you'll see Word disappear on the console. So that's essentially what it takes to get command and control. And we'll go ahead and exit out of that, and let's go ahead and kill our Trevor client, and we'll get it set up for our next attack. Now over here, again, the user didn't see anything running, but there is actually a PowerShell exe running in the background, and this is the actual Trevor client that is running. So we're going to go ahead and kill that so that we don't have multiple connections going to our Trevor server. And we'll reset our web server over here by clicking down a couple of lines. Okay, so we're going to reopen our document this time, and this time we're going to hit no, and we're going to hit no, and we're going to hit no, and hopefully it doesn't run. I've seen it actually run sometimes, so sometimes you get a surprise here. Now we're going to delete our DDE attack, replace that field with the period, and now we're going to actually go in and talk about macros for a minute. So let's go into our macro, and what you're going to see here is that this macro this is a very innocent macro. Again, all it's going to do is it's going to update the fields that are in the document. Now, this next attack, we're actually going to create a macro-based attack. So we're going to want to delete this innocent macro. And strangely enough, we're going to replace it with a macro that is just as innocent. Okay. So this macro is technically just as innocent. There really isn't anything in this macro that is going to trigger any sort of security product that this is something really, really bad. But it is actually bad, but it's only bad when it actually runs the Trevor client code, for example. Now, this document is cross-platform weaponized, meaning I can attack a Windows box or I can attack a Mac OS box. And when I originally recreated this attack from the original findings that we had on this attack, I was curious about why they attacked a specific version of Office on the Mac. They specifically targeted Office 2011 on the Mac. And I really wondered why they did that. And it took me a while to figure out, I did some research to see if there were different vulnerabilities or if there were different commands or something that could be issued. And actually what I found was that they, as you may know, APT32 or Ocean Lotus is essentially predominantly a Vietnamese-based attack group. And they, at least at this phase, they were attacking predominantly other Asian entities, governments and businesses and institutions. And so I had to think about the motivation behind the attack. Why would they, what is the correlation between something like Office 2011 for the Mac and other Asian entities? And then it came to me what a potential reason for that might be. And the reason I figured that it might be is that they attacked Office 2011 because Office 2011 was the last version that you could perpetually license with a license key, and it would never call into Microsoft ever again for a license check. So if you had a large group of people, let's say, that were running pirated versions of Office, you could actually attack that. So they originally attacked that, and this is really very close to their original attack code. I did modify it slightly. I fixed it so that we could, if we chose to, we could actually attack a newer version of Office. And then, of course, I fixed this to make it a heck of a lot more legible and follow it a little bit easier. But this is a pretty easy macro to follow. Basically, what they're doing is they built a very innocent looking macro, essentially to bypass anything looking for strings or patterns that would potentially be malicious. There's no URLs or anything else in this document that's not in a comment code anyway that could be picked up on. The reason that they did that and how they bypassed a lot of the security that was out there today is that they base64 encoded the strings that have actually the bad commands in them, and they actually built in a base64 decoder. In fact, this is an open source decoder. It's been around for a very long time, and they just cut and pasted it directly into this document. And I've made no changes to this part of the code, so it's just as it is. And again, like I said, it's completely cross-platform, meaning if it's a Mac, it's going to execute a Mac command. If it's a PC, it's going to execute a PC command. Now, where does it get these commands? Well, it gets these commands from the comments field and the company field in the document itself. That'll make a little bit more sense when I show you how those are actually edited. The great thing is that we're actually completely done weaponizing this document at this point. So we're going to go ahead and close our macros. And then we're going to save our document as a different document. And the reason we're going to do that is so that we can get the yellow box back again to control whether or not we want to actually execute those macros. Okay, so we've got our new document, but it's not weaponized yet. It just has the macro VB script in it, but it does not actually contain any weaponization. We haven't told it where to get the Trevor client. We haven't told it what to execute, etc. So we're going to do that now. And as you remember from the macro, we need to do this in a base64 encoded format. So what I've got here is I've got some to pre-create these to make it a little bit easier to use. We're going to take this PowerShell command here, which is basically the same as we had before in the DDE. And we're going to put this into a tool called CyberChef. And for you, in your environments, you really should be using CyberChef if you're doing any sort of encoding or decoding. It's a really cool and easy tool to use. So we're going to simply paste in our command. And remember, we have to point it to the URL of this little simple web server running here in the bottom left-hand corner. So that's pretty easy. We just type this in. Put in the IP address, the port number, and Trevor C2, Trevor C2 client PS1. And again, we're going to download the PS1 and execute it directly into memory. And that's very important. Again, we're not going to store the file on disk. The only file that's going to be on disk is going to be the Word doc. Now, it's really easy with CyberChef to create a base64 encoded format. You basically just paste your text in, you go over here and you grab the to base64 and you drag and drop it here, and all of a sudden your text is now in a base64 encoded format. So we grab this text down here, we copy it into our memory, and we're going to place it into the document. Now remember, from the VB code, these are placed into different fields, and where those fields are is in the metadata of the document. So we come in here to the document properties and go to the details. Now, the PC code is placed in the company field of the document, so you just paste that base64 encoded blob of text directly into that field and hit OK. So this is really cool because you never have to open the document again. You actually can change the URL, change the weaponization by simply modifying the properties of the document. So on the Mac side, it's a little bit different. We've actually got to create a Python browser essentially to do our connection. So that's what this code is for. Essentially, it's going to create a Python browser. And again, just like we did on the PowerShell script, we have to put in our URL, and we're just going to enter that in. Oops, don't forget the port number. And on the Mac, we're going to execute the Python client, okay? So now that we have the weaponized URL in, we're going to convert that to base64, so we get this big blob of text. Now we have to use, on the Mac side, we actually have to use a second piece of Python that I call a wrapper. And this wrapper essentially is its own base64 decoder again, but this time where we have our blah text, we actually have to take our URL, or our browser essentially that we built in Python, and we put that into the blah text there. So now we've got a command that's basically going to base64 decode and execute that base64 encoded Python browser and go to that URL. Now, because we have another base64 decoder in the document itself, we need this entire command encoded into base64, giving us this great big block of text here. Now, just like we did with the PowerShell command, we're going to take this block of text and we're going to paste it and put it into our document properties, into the comments field. And now the document has been weaponized for both PC and Mac. Makes it a lot of fun. Okay, so while we're going to run this, we're just going to go ahead and copy the document over to a shared drive so we can transfer it over to our Mac. Okay, so time to run this again. So let's open our document. Now again, remember that we saved it as a new document, so therefore we're now asked again whether or not we want to run our macros. Now the cool thing here is that if you get somebody used to opening a document with macros and used to clicking the yellow bar, maybe you send them a few legitimate documents before you send them one that is weaponized. Again, you're trying to exploit the trust of the end user. So they would have seen this, they would have known that the macro is only going to update the name or the other fields or whatever, and so they innocently click enable content. And when this runs, hopefully here within a few seconds, if we didn't do any typos or anything, we will see the traditional connection over here on the left. And sure enough, we do see that we have a new connection. We can now interact with that session, and we can do the same things like we did before. We can kill Microsoft Word on the right, just like that. So just like we had before, we now have a macro weaponized document that allows us to terminate and kill the or command and control or do whatever we want to do with that remote system. And we'll go in here and we'll end the PowerShell task. So that's how easy it is to create an obfuscated command and control into a Word document using macros. Now, again, because the text is base64 encoded, there's nothing that a security tool is going to pick up on, and there's nothing that it's going to be able to essentially see to defend or detect that that is actually a malicious use of a macro. Now, as I promised earlier, we're going to take a look at this on a cross-platform system. So I actually happen to have a Mac box, and here's my resume that I had on that file share. And to recreate this attack in its entirety, this machine is running Office 2011, just like the original attack. So we're going to open up our resume, and very similar to Windows, we get a pop-up. We don't get to see the document on the Mac, but you have to make the decision before you can actually see the text of the document or anything there. So the social engineering for this really needs to be in the email or the phone call or whatever it is to trick the user into going ahead and saying enable macros. And hopefully, if everything went well, we're going to see the hit of the web server as well as the connection of the command and control client on the attackers over here. And yep, sure enough, you can see we did actually get the download of the Python client this time, and we have interaction with the server. So we can actually take a look. We can now interact with session 1, and we can now issue Windows commands, or and we can now issue Linux commands or BSD commands for the Mac system. Okay, so now that we can actually issue commands, one of the interesting things I want to try to do is I want to try to extract the iTunes or iCloud password from the user on the Mac. So let's bounce back over here, and I have this command already written. Let's grab it. And this is basically going to prompt the user to enter their iTunes password, which for Mac users happens a lot. And we're actually going to tell the application iTunes to do this. So what we're going to see is we're actually going to see the iTunes application launch on the Mac over here when we enter this command. So let's go ahead and send it. And you'll see over here, just like every day on a Mac, you get asked for your password. So the iTunes application starts bouncing. We click on it, and it asks us to verify your iTunes password. And it's got the right icon and error message and everything. So you go ahead and enter your password in. And you click sign in. And over here on the command and control, the command that gets entered, the returns comes back, and it actually says, this is my password. So there you go. This is a weaponized document that you can use to extract somebody's iCloud password or whatever from a Mac. And in this demonstration, we showed how easy it was to essentially attack both a PC and a Mac with the exact same document.
And that concludes our demonstration. Let's go back to our presentation and talk about how we can, as an IT industry, combat these fileless type of attacks. One of the things we can do is continually look at our tools, technology, and people and gauge the effectiveness of our existing solutions. So adding fileless attack simulations to our existing exercises, test your users, make sure they understand what's going on. We could utilize GPOs and registry entries to enforce policies around macros and DDE, but again, this is a very draconian lockdown type of approach and doesn't really help us get our job done. We also can look for solutions that go beyond the basics, that go beyond standard on-disk malware detection, etc., but actually begin to look at things like PowerShell usage and script usage and things like that. And we can always implement new tools and continually re-verify. Continual education with our employees and our partners, and always testing improvements.
I really appreciate your time today, and I thank you very much for hanging out with me and learning how easy it is to attack both a PC and a Mac using the methods and techniques of Ocean Lotus. Thank you.